Hello everyone, welcome back to Coders Project. Today we're going to be solving the same tree problem on LeetCode. It's an easy level question, but it's packed with important concepts about binary trees that you're going to encounter in a lot of coding interviews. So grab your favorite coding setup and let's dive in. Go ahead and pause the video and take a quick look at the question. Alright, so here's the problem. We are given the roots of two binary trees, P and Q, and we need to determine if these trees are same or not. So basically, what does the same mean over here? They're same if they are structurally identical, which means their shapes match up perfectly, and the nodes in the corresponding positions have the same value. Let's take a look at this example. So we have 1, 2, and 3, 1, 2, and 3. These are same because they both have the same structure and the nodes match exactly. But in this example, 1, 2, and then 1 null and then 2. This is not the same because the tree, Q tree, has a null in the left child of the root, but then the P tree has a 2 in the left child. So these are structurally mismatch, so we go ahead and return false. So let's dive into it. What we're first going to do is we're obviously going to use recursion for this problem because it's a natural fit for these kind of tree problems. We'll think of it like, let's go ahead and tackle the edge cases. If both the nodes are null, we can return true because two null trees can have the same values, or they considered same. And if one node is null, then the other isn't, then we go ahead and return false. And then finally we check if both the nodes are non-null, and then we check if their left subtrees are the same and if their right subtrees are the same. If they match, we go ahead and return true, otherwise return false. So let's jump into it now. What we're going to do is we are first going to return true if both the trees are null, if not P or not Q and not Q, we return true. But if one of them is null and other isn't, then we return false. If not P or not Q, return false. And next we're going to check if one node is none while the other isn't. The trees are in the same, and then we check the values for the current node, and if they are not the same, the trees aren't identical. So if P dot val is not equal to Q dot val, we return false. And then finally, we can go ahead and compare and make our recursive calls for the left and right subtrees. And then this is going to ensure that both left and right subtrees identically match. And then if they are, then we can go ahead and return true. If not, it returns false. So return, we're going to call this function recursively for the left subtree first, p dot left comma q dot left, and then for the right subtree, p dot right comma q dot right. Talking about the efficiency, the time complexity for this is big O of n, where n is the total number of nodes in the smaller tree. Why? Because in the worst case, we'll visit every node once. The space complexity is O of h, where h is nothing but the height of our tree. Let's go ahead and run the code. Okay, let's look at this. We gotta add self over here because it's inside our class solution. Let's rerun it. Alright, all of our test cases are passed. And that's it. We have broken down the problem, walked through the logic, implemented the solution now, and we have also analyzed the complexity for this. I hope this video was super clear for you. If you found this helpful, make sure to like, subscribe, and share my video. Also drop a comment below if you'd like me to cover more binary tree problems or any other topics. See you in the next one.